Hello, so continuing on problems from Biweekly contest 134. The second problem is maximum points after enemy battles. So basically here we have you as a player and you have enemies, and we get your energy, initial energy, and we get the energy of different enemies, right? And we start out with 0 points. And all the enemies are initially unmarked. So this is a pretty classical type of problems where you start out with some score, some points, and you have adversaries or enemies, and you are there are some operations you perform to get points, and the goal is to maximize your point. That's essentially the gist of this problem. And so what are the operations we can perform here? So, and we can do no operation, or we can do as many as we want, right? And so there are two types of operation. There is the first one here and the second one. Now for the first one, we can do it only if our current energy is bigger or equal to the enemy energy. We can pick one enemy at some position that has not been marked yet. So we mark enemies under some conditions. We'll see what that condition is. But so if our current energy is bigger than or equal to the one of the enemy's energy, then we can basically sort of take 1 point, again 1 point, and then our energy would be reduced by this enemy's energy. So let's say we had 5 as our current energy value, and then the enemy had 3. Then we gain 1 point, but our current energy would be reduced by 3, so the remaining value would be 2. So after this operation, our current energy would be equal to 2. Okay? And we can do this as many as we want, which means basically, let's say if our current energy is maybe 10. Okay? Then that means the same person we can gain from the same enemy, we can gain maybe 3 multiplied by 3, because, right? That's still 9, smaller than 10, right? So we can get, and we would have remaining energy 1. So we can get 3 points out of this person. This is a key important point. I will go back to it in the solution, but it's a key point in this problem. Okay, so that's the first type of operation, is you subtract the energy of the enemy from yours, but you gain 1 point. The second type is, but for the second type of operation to do it, you have to have at least 1 point. And it's basically you increase your energy by the enemy's energy value. You don't have the constraint of having to be bigger or equal, because you will get additional energy. But then once you do that, the enemy at that position is marked, which means you can't use it anymore. So it's not like this one where we can use it multiple times. Once we use it, we can't use it anymore. Okay? Now the goal is to maximize the number of points we can get. So for example, if we take a look at the first example here, initially it's 2. So what we can do, we can take this one. Our energy would become, our point would increase by 1, right? But our energy would decrease by 0, so now our energy is 0. So we can't do the first operation anymore because the smallest one is 2, but our energy is 0. So we do the second operation, which is take 3, and it makes sense to take 3, enemy 3 instead of taking 2, because we'll get a higher point. It always makes sense to opt for the higher value. And so we take 3, and now 3 is marked. Okay, so now 3 is marked, we can't take it anymore. And our current energy is now 3. Okay, the points is still 1. The second operation doesn't increase points. And then we take this one again, 2. So increases our point by 1, so now our points is 2. But it decreases our current energy, which was 3, by 2. So now we have 1 left. Current energy is equal to 1. Okay. Now we can't take again 2 because our current energy is 1. So let's do the second operation, which means increasing our energy by 2, marking 2, and then our current energy is 2 plus 1, so it's 3. But this one is also now marked. Okay? And then we do the first operation again, because now we have 3, we can take this one, so we take it. And then our points is 1. And now our points is equal to 3. Okay? But After we do that, our current energy is 1, so we can't take this anymore, so we try operation 2. Operation 2 will increase our points by 2, so now we have 3, but there is nothing anymore to do operation 1 on. We are done. And so we finish, we return the number of points we have, which is 3. Okay? So that's the idea. So when are we done? We are done when everything is marked, when all the enemies are marked. Okay? So that's the idea. Now, if you take a look at this type of problems, usually either there's one of two possibilities, right? You could either find the greedy approach that works, or you could try all combinations and maybe use some sort of heuristics to not explore many paths. But if you take a look at the constraint, it's the number of enemies is 10 to the power of 5, so it's simply too big, so this one is unlikely, right? But we can actually do greedy. How? Let's think about it. So if you think about it, if you take a look at the operations we can do here, when we do the first operation and gain points, it always makes sense to take the smallest enemy value, because we would have to subtract it from us. So if we take the highest one, then that would reduce our likelihood to get, to be able to take the second point, right? So it always makes sense to take the smallest one for this operation. For the second type of operation, it always makes sense to take the biggest one, because we are adding the value to our energy, and we will mark the point. And so the first advantage of taking the highest value is our energy value would be bigger, so we'll be able to take more enemies because we would have more chance of the value being bigger, and so we'll get more points, which is our goal here, to maximize the number of points. But also the other advantage is if we mark a higher value, we no longer need to do it here, so what's remaining is the smaller values, and so the subtraction would be with the smaller values, right? So we know for operation, basically with the greedy approach, operation 1, always take the smallest value. Okay? Best to always take smallest unmarked value. And then for operation 2, it's best to always take the largest unmarked value. Okay? So those are the heuristics we have. Now for this operation 1, there's an interesting thing here happening, because what I mentioned earlier, if you remember, is that if the current energy is 10 and this is 3, it makes sense to take this 3 times and get 3 points, right? Because we can do the operation as many times as we need to, and we want to maximize the points, so may as well just take as many as we can, which is 3. And our remaining energy would be, of course, 1, and so we will try to do the operation 2. But it makes sense to maximize the number of points we can get from the smallest energy value. Okay, so that means for this operation 1, take as many as current of the smallest value, right, as current energy allows us. Okay, and with these two heuristics, that's all we need to do for our greedy approach. Now you can see here we always take either the smallest or the largest, so that tells you we need to sort. So I'll just mark this as enemies just to make it easier, and just call this current. Okay, so we need to first sort current here. Okay, and then second, what we should do is just go through and collect the points, which the maximum points we can, and then return that at the end. Okay, so we know that here we mark a value, so once we take it, we mark it. So let's just have a position to tell us, we want to take the largest, to tell us which ones we already took, right? So let's just have this be enemies -1, last position, so that each time that we mark an element, we just push the index to the right. Okay, what I mean by that is, let's say, for example, in this first example here, so once we sorted, it would be 2, 2, 3. So first, J is here. When we mark 3, which happens, I think, here, we just advance our j to the left so that this we never consider this one again because we already took it. Okay, so that's the approach we are doing here. And when are we done? When there are no more elements in the list. So when everything is marked. When is everything marked? Well, basically when g is no longer, when g is less than 0, because that means we already considered all of them and marked them. Okay, so while j is bigger or equal to 0, we can keep going forward. Now we said if we want to check if we can do the first operation. To be able to do the first operation, we just need the current energy to be equal to the smallest, to be bigger or equal to the smallest value. What's the smallest value? Well, that's just the first position, right? And this one will always be available until all the elements are marked, because remember, j goes to the largest value first. We always mark the largest values first. And so if this is the case, then we said we want to take as many as we can. How do we know how many we can take? So let's just calculate. Well, remember the example 10 and the enemy energy is 3. Well, we can take 10 divided by 3. That means we can take 3, which is 9. And so that's just current divided by enemies at position 0, the smallest value. So this will tell us how many we can take. Now, how many we can take, that's the number of points we gain. So points plus count. But current also reduces by the energy. Each of these subtract from our energy, which is basically count multiplied by the value. So like this. Okay. And then we can do else here, which means we can't do the first operation, so we do the second operation here. But we can do the second operation only if points is at least 1. So if it's bigger or equal to 1. Now what's the operation we can do? Well, the operation increases our count by the largest value, which is the one at position j. So we can just take enemies at position j. But once we do that, we mark the element. So let's say we take 3. We mark 3, which means we shouldn't consider it anymore. And so let's just move j to the left so that we no longer look at it. And so we just do j minus 1. And since the list is sorted, this would be the second largest after we take this largest one. Okay. Now, what if for some reason we weren't able to either take the first one, because let's say current value in this specific first example, let's say the current was 0. So we can't do the first operation and we can't do the second operation either. So in that case, if point is still equal to 0, then we should break because we are stuck. There is nothing we can do. So that's just to handle that. So let's run this, submit, and this gets accepted. Now in terms of time complexity, we are doing j and each time we advance it. So here we can actually just do if like this as well, because we don't need the else, because we exhaust all the possibilities of using the smallest value. So, and this is easier to reason about the time complexity, because as long as either points is bigger or equal to 1, in that case we decrement, or it's equal to 0, in that case we leave the loop. So this tells you that this loop, on each iteration, either it exists, it terminates, or we advance the pointer by 1. And so this loop runs of n time, n being the length of enemies. So overall, this is of n time. In terms of, so this loop is of n time, but this sorting is of n log n time. So overall, the time complexity is of n log n time. In terms of space, we are just using extra variables, but nothing new. And so it's of 1 space. So of n log n time of 1 space. Yeah, so that's pretty much it for this problem. Thanks for watching and see you on the next one. Bye.